So the primary motivation of this course, as well as most of the courses that we run, is the importance of systems engineering, application of systems engineering principles to the design, development, and operations of electric vehicles. Electric vehicles being relatively new technology, although electric vehicles were made nearly a century back, but the real large scale or mass adoption is going to hit us, or is right now hitting us. And that's why the technology is not as mature as IC engine technology that we are trying to migrate from. Second aspect of electric vehicle is we have motors and batteries, which are not the core competencies of, or the areas of core expertise for the traditional vehicle manufacturers, or OEMs as we call them. So we have them coming out of IC engine era. The technology has been largely governed by the automotive industry. The development of all the IC engine related technologies has been more than 99% coming out of the automotive industry. And there are other applications which are not as demanding. We have fixed energy or power generation using gensets. We have marine applications, and there could be others as well. But primarily, the IC engine is used in automotive sector. We have a lot of reduction in usage of IC engine, diesel IC engines in railways. So mostly it is now in automotive sector, and that has been what even I come from automotive industry background, having worked on IC engines. We are habituated to having IC engines, controlling the technology of the IC engines. We are habituated to just walking up to the department which deals in design and development of IC engines, and having changes during the program. Same is true with some of the suppliers as well, to provide fuel tanks, to provide other auxiliaries, after treatment systems. However, motor and battery have not been traditionally the forte of automotive OEMs. And that is why managing the change of one of the most vital subsystems of automotive vehicle, which is powertrain, becomes very important and challenging now. It is quite different from what it was in IC engine vehicles or products. So that is one of the primary motivation of this course, to understand how significant it is to integrate a battery pack in particular into the electric vehicle. What are the different aspects of the integration? And the second underlying theme that we have is the use of virtual tools, or system models as they are often called, for development process, the integration and development process. So these tools are really helpful in making lot of early decisions and lot of later validations. So right from what kind of battery to use, what chemistry to use, what kind of configuration to use, down to how it should be integrated into the vehicle, what is the mass of the battery that can be carried into the vehicle, because battery, as we will learn, are very massive subsystems. They account for up to 30–40%, sometimes even 50% of the total vehicle mass, depending upon how big a battery it is. So it becomes extremely important to understand the aspects of batteries from the perspective of a battery integration. And that's what this course is all about. So this is the content and the schedule. This has been circulated through our brochures. Nonetheless, this will be available as a reference to everyone. So in all, we are going to run this program a little over 7 weeks. On alternate Saturdays, we will have sessions to mentor and to troubleshoot the models that you would be building. So the sessions that we have would be typically a mix of theory and modeling. If you have if you have two screens, for example, or more than two screens attached to your computer, you can use those two screens by having one screen showing what we are doing, and on another screen you can work. If that is not something you have, you can actually refer on another device the video on the LMS, the recorded video on the LMS, and work on the computer following how the modeling is done. So that facility is available whichever way you want to do it. In the Saturday sessions, it will be all you. We will be looking at your screens, your models, your issues with those models, trying to troubleshoot them. Also giving you insights into what are the best assumptions, what are the best practices of modeling, how you can overcome certain issues, and so on. Okay, so that's the overall structure. We have in all five modules: battery basics, EV application, battery management system, which is the controller of the battery modeling and simulation, and then finally the charging system and charging and other ecosystem on which the battery in an electric vehicle depends heavily on. Yeah. We will have a final exam in terms of a multiple choice quiz. And then we will also have a mini project running through. So we will have assignments on each of the module. Sometimes we'll club two modules together in an assignment. And we will also have a mini project of which we'll allocate the topics, we'll create the groups or teams, and that will have an internal evaluation. So the mini project, because it's a direct application of what you learn, will have 50% weightage in the overall scoring of this training program. Okay. So I'll not go through very too much detail of what the assignments would be and all. We will take that as we go forward. However, important thing to note here is this program is a certification program where the certificate is provided on qualification, not on participation. It's not a certificate of participation, it's a certificate of qualification that you have acquired these skills. And that's why the certificate has more value, because it will be accompanied by a statement of marks as well, based on the four criteria that we mentioned. So you will have to engage, you will have to go beyond just participating in the live session. You would have to do some homework, some assignments, some modeling work on your own, and also the mini project. So, however, let me assure you, we have extremely rare cases where people do not qualify, because we engage all the participants to the level where they can actually execute and qualify for all these criteria by the end of the training program. Then we'll go through some trainer introductions. So Rahul Pagria, he is the co-founder in EV Academy. He is my friend and partner. He has dual degrees in masters, dual master's degrees in robotics and control from University of Michigan. And he has 20 plus years of experience working in energy sector, in utilities, in e-mobility. He has worked extensively on chargers, electrification roadmaps for different countries, including India, different sectors like commercial vehicles, personal mobility, buses, and so on. He is also the member of the task force for charging infrastructure standardization in India. Coming to me, I am Vikrant Vaidya. I have a master's degree in energy systems engineering from University of Michigan. I also have 20 plus years of experience in automotive industry. I started off in Tata Motors in 2001. I worked on both IC engine vehicles as well as hybrid vehicles, from Tata Motors to General Motors And later through Tata Consultancy Services, I have worked for Jaguar Land Rover as well as Peugeot Citroën. I have worked on hybrid electric vehicles. I have worked on battery electric vehicles or the pure electric vehicles for emerging markets. I also have a few records of invention in hybrid powertrains as well as battery controls and recycling or repurposing of the battery. With that, I will have Vikrant Garu. He will also be the master trainer for this program. I will let him introduce himself.
Thank you, Vikrant sir. I'm Vikrant Garu. I'm with 7+ years of experience as a researcher come academician. I have expertise in advanced and smart automotive materials, and I'm working on implementation of it for the various automotive applications. I also worked on various projects of PRD, CVRD, and published around 20+ research articles in the premium journals. I also listed in Fisita's World Database of Expert and also a part of editorial board of Elsewhere and Taylor and Francis since last 3 years. Thank you.
So we will be using two tools predominantly in our training program. One would be a spreadsheet calculator. Most recommended is MS Excel, Microsoft Excel, part of the Office suite. But it is not a necessity for you to have Excel. If you are using some other spreadsheet like LibreOffice or OpenOffice or even Google Sheets, that's not an issue. We will not be going into any developer options, no macros, no Excel, Visual Basic, nothing. Just programming each of the cell with certain physics-based formula and generating the outputs. So any spreadsheet calculator will do. However, if you have access to Excel, I will encourage you to use Excel. Typically, we do all the sizing or any other initial calculations with Excel. One question is whether we will be sharing these Excel files with you. It's not required because you would be doing that watching the tutorial or a recorded tutorial. So you will all be capable of creating these tools. That's what, in our opinion, gives you confidence to use those tools. Even in my all the past experience, I find it extremely hard to work with black box tools or someone else's developed tools. I have to understand the tool, and then I have the full confidence of what are the assumptions behind these calculations, where they are valid, where they are not, where it becomes a stretch. So all those things will be very easy for you to work with if you create those tools. Yeah? And don't worry, we will help you. By the time we finish this training program, you would yourself feel motivated, as well as you yourself will feel comfortable creating these tools, small calculation tools in Excel for your own use. Another tool we will be using extensively is the modeling tool, which is Scilab, which is called Scilab. It is a freeware. It is very, very similar to MATLAB Simulink, to the extent that I myself have worked for over 16 years in MATLAB Simulink, and I could migrate to Scilab within a few weeks, not even a few weeks, a few days. Yeah. So it is very, very similar to MATLAB Simulink. Wherever there are parallels, I will definitely talk about those. And if you have access to MATLAB Simulink, there is no need for you to again go to Scilab. You can use MATLAB Simulink also to do the modeling. We can mentor you on MATLAB Simulink as well, not an issue. Yeah. So we will provide a recorded session of the very basics of Scilab. How to open it, how to find different applications inside this platform, how to create very basic scripts, how to create very basic models in the user interactive app called XCOS, which is the modeling tool, how to set up the equations. We will provide a tutorial, and we will also do the live modeling using Scilab in our sessions. So these are the basics of what you will see in the next 7 to 8 weeks. Some admin related stuff. There will be a survey floated by us for you. It will be in 3 parts. One will be your self-assessment on the skills that you can expect to gain in this training program. Then there will be some personal details required, that is more for certification. And then we will also ask you the choice of your project topic, or at least the area or the domain in which you would like to do your mini project. So you'll have a week's time to take this survey. It would be great if you can finish this survey and provide your references.